In this video, we're going to talk about like terms, how to identify like terms, and then how to combine like terms. Like terms are terms that have the exact same variables raised to the exact same powers. So let's go and look at some examples. Here you'll see I have terms that have the x variable, terms that have the y variable, and terms that don't have a variable at all. And so if we're looking for the exact same variable with the exact same exponent or power, you'll notice that the 4x and the negative 3x are like terms. And the 3y and the negative 2y are like terms. And then finally, the 7 and the 8 are also like terms because they both do not have a variable. This one is a little bit harder because it has a few more letters. And we look at here and we see, let's see, a 5a. And then what's like the 5a? Do you see anything else that just has a plain old a? Yep, right here. And then the 3y squared, is there anything that matches the 3y squared? No, it's all by itself. All right, next one. The 7t. Is there anything here that matches the 7t? Sure, over here, the 2t. And let's see, I'm running out of colors. Okay, here's a color. What about the x squared? Do we have anything here that matches the x squared? Sure enough, the 4x squared. They both have an x and they're both at the power of 2. And then finally over here, our lonely little 8 is going to be a term by itself also because there's nothing else that doesn't have a variable. When you're identifying terms, those plus or minus signs becomes their positive or negative signs. And so when you circle them, you want to circle the sign that's in front of the term. Not behind the term, but in front of the term. So we'll start with the 4x. Does the 4x have any plus or minus in front of it? Well, no, not usually if it's in the front of an expression. So it's just regular positive 4x. Do you see its like term? Sure, over here. And here I am going to circle the negative because it's not just a 3x, it is a negative 3x. All right, let's go with the 3y over here. I have a 3y. I know I said circle there, but you can also square it. And that's a positive 3y. So what else is like the positive 3y? Well, the negative 2y. And again, they have to have the exact same variable with the exact same exponent. In this case, you don't see the exponent, so it's just a 1. And then finally, let's look at the 7 and the 8. We have a positive 7 and we have a positive 8. Knowing that, having the sign there is going to help us when we combine like terms to know whether we're going to be adding or subtracting. Stop this video, write down this expression on your paper, and go ahead and identify the like terms. Okay, hopefully you're back. Hopefully you did that. Let's see if you remembered that one thing we just learned a second ago. We have our 5a, and 5a is going to combine with positive 16a. Did you remember to circle the plus sign? All right, if you didn't, you want to go back right now and fix that in your notes. Positive 7t, do you see anything? Oh, sure enough. So we'll have positive 7t here, and it's with the negative 2t here. They have the same variable. And then finally, we're going to deal with the x squared. We have a negative x squared here and a negative 4x squared. Now, just out of curiosity, do you know what the number, the coefficient is of negative x squared? Do you remember what number can multiply times something and it can be invisible? Well, that number is 1. So that's literally the exact same thing as 1x squared, which might become kind of important when we start to combine like terms. In combining like terms, we are just adding or subtracting the coefficients. Remember, those are the numbers in front of the variables, and keeping the variables. So this first one, 7x and 2x, is 9x. One way to think about it is just throw out, instead of the word x, apples. If I have 7 apples and I have 2 more apples, yeah, of course I have 9 apples. So same thing here, 7x, 2x is 9x's. 5y minus a y. Now remember, what number can go in front if we don't see it? The number 1. And what is 5 minus 1? 4. So we have 4 y's left. Now let's look at this next one. Are all of them the same term? Well, no. We have an 8k and we have a positive 3k. But the 6 is not like those two. So I'm going to put together the 8k plus the 3k. See how it's really important to have that plus sign there. It tells us what to do. So 8 plus 3 is 11k. And then I'm going to just say plus 6 at the end because 6 is just by itself. Finally, let's look at this last one. Same exact sort of thing. We have 10r. We have a negative 3r. So 10r minus 3r. 10 minus 3 is 7r. And then we're going to just tack on the end the minus 2. This is the last one. And again, I would love for you to just pause the video, write this down, and see if you can combine like terms successfully. And then if you can't, don't worry about it. We'll fix it once I come back on. Okay, here we go. I have a 5x to the power of 3, and I saw over here I had a positive 7x to the power of 3. Now this x to the power of 3 is not the same term as x to the power of 2 because remember, they have to have the same variable and the same exponent. And 3 and 2 are not the same. All right, let's put these together. 5 plus 7 is 12. X to the power of 3. Alrighty. And then I'm looking here and I see that I have a positive 3y and a negative 2y. So 3 plus negative 2, or you can say 3 minus 2 is 1. So I'm going to put it over here. 1y. That's what this is going to be. Right here, these two combined. But if one can be invisible when they give us the problem, then when we write it down, it can continue to be invisible. Alrighty, and then what do I have here? I have a negative 4x squared that is just basically all by itself, and I am done.